For the lesson 15 problem set, we're going to look at the standard subtraction algorithm when solving problems. And I mentioned this in a previous video that you can look at each place value and decide whether or not it's prepared for subtraction ahead of time or do it in the moment. When I go through, I can look, and it doesn't matter which order. You know I like to go right to left, but when I look here, I know that this 0 minus 0 is good. 6 minus 8 is not good. 6 minus 6 is currently good. 1 minus 1 is good. 0 minus 9 is not good. So what happens is, if I borrow from here, this 0 becomes a 10, making this acceptable. The 1 is good, the 6 and 6 are good, but the 6 and 8 are not. And so when I borrow from here, what happens is this becomes 16, which is good, but this 5 is now below the 6. So I actually have to borrow again, which makes this 0, which means the thousands place is out of balance. So I have to borrow from the 9, or from the 10, to make this 10. And so what I've done is I went through and I made sure all of the numbers on top were prepared for subtraction. So when I look quickly, 0 and 0, good. 16 and 8, good. 15 and 6, good. 10 and 1, good. 9 and 9, good. 0 and 0, good. When I do this, 0 minus 0 is 0. 16 minus 8 is 8. 15 minus 6 is 9. 10 minus 1 is 9. 9 minus 9 is 0. 0 minus nothing is 0. Okay? So we're preparing the top line before we go any further. So the 1 and 2, I know I'm going to have to borrow from this to make this 11. We're good here. 5 and 0, still good there. 5 and 7, I'm not good. So this 2 is going to become a 1. This 5 is going to become a 15. Now, this is 1 minus 4, and I know I can't do that. So this becomes a 3, and this 1 becomes an 11. 3 and 4 I cannot do, so I have to borrow from the 2. This becomes a 1, and this becomes a 13. So now I'm just going to check. 11 minus 2, that's clear. 5 minus 0, clear. 15 minus 7, clear. 11 minus 4, clear. 13 minus 4, clear. 1 minus nothing. So 11 minus 2 would give us 9. 5 minus 0 is 5. 15 minus 7 is 8. Sorry, I wrote a wonky 8. 11 minus 4 is 7. 13 minus 4 is 9. 1 minus nothing is 1. And the reason why you might want to consider unbundling and checking all the place values is it allows you to not make your subtraction so choppy. A lot of times, if you bounce back and forth, you can get lost of where you left off, especially if it gets messy like it is here. In this problem, I have digits all in here, at least to this point, and not in here. So I know I'm going to need to borrow from this 1, which makes it 0. This becomes 10, but I'm going to need to borrow, making this a 9, which makes this a 10, but I'm going to need to borrow for this place value, making it a 9, making this a 10. I don't need to borrow for this place value, or this place value, because they are all zeros. 0 minus 0 minus 0. So 10 minus 2 is going to be 8. 9 minus 9 is going to be 0. 9 minus 5 is going to be 4, and 0 minus nothing is 0, and I don't have to place it there. So I had to take that 1 from the millions place and ungroup it or kind of break it apart. It's called decomposing the larger number to fill all the place values. Let's look at one more. I have the 600,000, but I'm going to need help in that 10,000 and 1,000 place. I'm also seeing I'm going to need help in that tens place and the ones place as well. So let's start here. 5 in the 100,000. That allows me to make 10 10,000s, but I need help in the 1,000. So this becomes 9, and this becomes 10. The 6 and 5 are okay, but this 5 and 6 are not. So 6 becomes a 5. This makes this 15, but I need help in the ones too. So the 15 becomes 14, and this 8 becomes 18. 18 minus 9 is 9. 14 minus 6 is going to be 8. 5 minus 5 is 0. 10 minus 2 is 8. 9 minus 9 is 0. 5 minus 5 is 0. And what I have is zeros in the 10,000s and 100,000s place. If I were to rewrite my answer, I would not include them because they don't have any value. They're just kind of place savers. So the answer to this problem would then be 8,089. And again, what you're ended up doing is you're going to have to borrow from a larger place value to prepare for the other place values. It says use a tape diagram and standard algorithm to solve the problems and check your answers. Luckily, we don't have to write statements. So it says David's flying from Hong Kong to Buenos Aires. The total flight distance is 11,472 miles. If the plane has this many miles left to travel, how far has he already traveled? So if I start with my tape diagram, I could just almost write it as a timeline, but total miles, right? How far traveled, how far left. Because we are in middle of the flight right now for David. We know that the total miles would be 11,472. The amount of miles left to travel is 7,793. So in order to find this other part, I could add question mark plus 7,793 equals, or I could take the 11,472 and subtract it from 7,793. When I look at my place values to make sure they're prepared, my 10,000 is okay, but my 1,000 is not. So this is going to become a 0, and this is going to become 11. In this case, my 4 is not able to be subtracted by 7, so this 11 now becomes a 10, and this 4 becomes a 14. Unfortunately, I cannot do 7 minus 9, so this 14 now becomes a 13, and this 7 becomes a 17. And once again, the 2 cannot be subtracted by 3, so this 17 becomes a 16, and this 2 becomes a 12. And I know this can be confusing. At this point, I'm able to do the ones place, 12 and 3. I'm able to do the tens place, 16 and 9. I can do the hundreds place, 13 and 7. I can do the 1,000s place, 10 and 7. And I won't be doing anything for the 10,000s. So 12 minus 3 is 9. 16 minus 9 would be 7. 13 minus 7 would be 6. 10 minus 7 is 3, and I would not need to record this 0. So if the plane traveled this far, how has it traveled? I also need to check my work. So I'm going to take this partial amount, 7,793, and I'm going to add it to what I think is my answer, 3,679. 3 and 9 is going to equal 12. 1 and 9 is 10, plus 7 is 17, carry the 1. 7 plus 6 is 13, plus 1 is 14, carry the 1. 7 and 3 is 10, plus 1 more is 11. Does 11,472 match 11,472? You betcha. So that means my answer is right here. I need to include a label, even if it doesn't ask for a statement. In this case, miles traveled. Continuing on to our exit ticket, more of the same. You know what I'm going to say when I see this problem. It has to be vertical. I'm writing it nice and big for you. No harm, we got the space. When I check, I can do this place value, but I can't do this one. So this 9 becomes an 8. This 5 becomes a 15. Can I do this one? Absolutely. So I can leave this 15 alone, leave the 6 alone. What about this 2 and 1? Yep, we're good there. What about 0? Uh-oh. So I'm going to borrow from this 2, make it a 1, and this 0 becomes a 10. But 4 cannot be subtracted by 9. So I'm going to borrow from this, make this a 9, and this 4 is going to become a 14. 14 minus 9 is going to give us 5. 9 minus 6 is going to give us 3. 1 minus 1 is 0. 6 minus 0 is 6. 15 minus 8 is 7, and 8 minus 7 is 1. Our answer would be 176,035. And I could go ahead and check it, but it doesn't ask me to. If I wanted to make sure I got it right, I might do that. Our last problem says a construction company was building a stone wall on Main Street. 100,000 stones were delivered to the site. On Monday, they used this many stones. How many stones remaining for the rest of the week? So if we know we have a total of 100,000 stones, on Monday they used 15,631 on Monday, rest of week. We're trying to figure that out. So this 100,000 minus, and I'm going to line it up right to left, make sure I don't mess up my place values. And I know I have values down here, not up here. So I'm going to do a lot of borrowing. This is 0, this becomes 10, which makes this 9, makes this a 10. But I'm going to need to borrow again, because each of these place values needed assistance. Subtraction. 10 minus 1 is 9. 9 minus 3 is 6. 9 minus 6 is 3. 9 minus 5 is 4. 9 minus 1 is 8. 0 minus nothing, nothing. So 84,369 stones used the rest of the week. What I could do if I wanted to guarantee my answers right is I could check the work by adding the 84,369 for the rest of the week, what I think is the answer, to that 15,631 to make sure it adds up to 100,000.